Now let's look at problem at model 2. It reads, solve for the area of the triangle. I'm going to try a different strategy to find the area of the triangle. I see that both right triangles share the same height. So here's triangle 1, here's triangle 2, and they're both showing the same height. I see that this acute triangle, if I copied it and I moved it up here, it would make a parallelogram. And I know that a formula for the parallelogram is base times height. And if this is an acute, if this acute triangle is half of that parallelogram, then I can still say that the formula for the area of a triangle, for any triangle, would be area equals half base times height, just like it is for a right triangle. In the previous problems, I added the two areas of each triangle together to find the area of the entire triangle. What would I do differently if I think about this as one big triangle? First, I need to ask myself, what formula do I need to solve for the area of the triangle? As I've just discovered, I can use A equals half BH. Next, I need to ask myself, what are the correct measurements needed? I first need to identify the base and height. I see that I have two measurements making up the entire base. I'm going to outline the base. This is the entire base, and the two measurements making up that base is 12.6 and 9 centimeters. So I'm going to add those together. I know that 12.6 plus 9, line up your decimals. I can add a 0 there. 6, 0.9, 10, 11. So now I have 21.6 is my new base. So the height can be found, by the location of the right angle, which tells me that the height of the entire triangle is 12 centimeters. So I can substitute H with 12 and B with 21.6. 21.6 centimeters was my base. My height is 12 centimeters. Now I'm going to multiply those together. So 21.6 times 12. Remember, when you're multiplying decimals, you don't have to line them up. 6 times 2, 12. 2 times 1, 2, plus 1 is 3. 2 times 2 is 4. 1 times 6, 6. 1 times 1, 1. 1 times 2, 2. Add them up. I have one decimal place, so I have one decimal place here. Next, I know that multiplying a half is the same thing as dividing by 2. So I'm going to go ahead and divide 259.2 by 2. Two goes into 2 one time. 2 goes into 5 2 times. 2 goes into 19 9 times. And 2 goes into 12 6 times. Bring up that decimal. And so now I have my final answer of 129.6 centimeters squared. Notice that the area found is the same answer as model number 1. We use the same triangle. This means there are two strategies to use when solving for the area of an acute triangle. I can either add the area of both triangles, or I can find the area of the entire triangle by adding the two bases together and then multiplying it by the height. So now on you try number 2, I want you to use this same strategy of finding the entire triangle by adding the bases first and then solving for the area.